Hi, this is Edmund, and this is my video explaining conditional probability, which is essentially a tool that any analyst in any industry will use to draw conclusions from data. So for our purposes, it's really easy to understand what conditional probability is if you have the context of what a decision tree is. Well, as you can see here from this very basic decision tree, is that it is essentially a form of drawing conclusions based on information that you have about certain things. For example, in this case, if I am hungry, then and if I have $25, then I will go to the restaurant. If I do not have $25, I will buy a hamburger instead. But what if I'm not hungry? Then I'll take this branch and end up here, which is go to sleep. So this is a more qualitative example. However, for our purposes, we have to understand it in a more quantitative form. So I know this seems a bit complex at first, but it's actually extremely simple. So you first start here from your root node, which indicates 1. This is because you have a 100% probability of one of these things happening. Then you go here, where you have R and RC. This means these numbers indicate that there is a 1/3 chance of the event being called R, or a 2/3 chance of it being called RC. So if we head down this path of the tree, you'll find that there is a 1/4 chance of it being RCT and a 3/4 chance of being RCTC. So if we continue down here, you'll see that there is a 7/8 chance of it being RCTC-LC or a 1/8 chance of it being RCTCL. Then these are your leaf nodes, which are at the end of your decision tree, where then you can find the probability of something happening. So the probability of RC, TC, and LC all occurring together is 2/3 times 3/4 times 7/8, which is equal to 7/16. However, you'll see that these numbers come from you just following down the path till the end. This is an extremely simple way of understanding conditional probability, which is essentially just the chance of something happening based on prior things that happened as well, which is essentially demonstrated here. So let's take this to an example that we might use it for. So in the case of an Olympic athlete and drug testing, in Beijing, for example, there were about 10,000 athletes, and they had to do drug testing, right? And so for a randomly chosen Olympic athlete, 2% of them took drugs, and 98% of them did not take drugs. Then, of the 98% who did not take drugs, 1% of them would test a false positive, while 99% would accurately test negative. For the 2% that did take drugs, 99.5% of them did in fact test positive correctly, while 0.5% of them would not and go scot-off free. So, what does this mean? Well, you'll see that if you use the concept of conditional probability that I showed you prior, you'll find that if you follow the tree, you'll see that the chance of someone having taken drugs and testing positive would be 0.02 times 0.995. Well, what if we want to extrapolate more data from this? So, something that you can figure out is the chance of anyone who's testing positive, how many of those people who tested positive are actually taking drugs? Well, let's see. So first you have to remember that probability is the chance of your desired outcome over your total outcomes. So my desired outcome is to find 0.02 times 0.995, which is the chance that someone who actually took drugs will test positive. Then your total outcomes would be the same number we just calculated plus the amount of people who did not actually take drugs times the percent that those people test positive. This number will eventually come out to around 2/3, which is 0.667. So you can see that even from just drawing down a single path, you can extrapolate that to make more conclusions, essentially. This is especially useful because in any single industry, for example, say the medical industry, you can see whether or not if someone who tested cancer, you can see that like the percent chance that they are actually cancer positive, or you can make predictions and market data for certain demographics of people based on information about them. For example, what their gender is, or where do they live, and how many children do they have, right? Those could be also represented in different nodes, like so. And then, based on those probabilities, you can predict what conclusions they'll come to draw. They will draw when, say, an election comes around. So there are basically almost infinite applications for this, which is why it's so important to understand this simple yet really broad concept.